Hey there, data enthusiasts. Let's talk about descriptive statistics. Imagine trying to understand a huge pile of test scores. Descriptive statistics are the tools we use to make sense of that pile, to summarize it and find the hidden patterns. These tools help us answer basic questions about our data. What's the average score? How spread out are the scores? What's the most common score? By answering these questions, we can start to understand what our data is telling us. Descriptive statistics are like the first date of data analysis. They give us a general feel for the data before we dive deeper. They're the foundation for making informed decisions, especially in education. Let's talk about three important measures of central tendency: mean, median, and mode. These are fundamental concepts in statistics. These guys tell us where the center of our data lies, helping us make sense of large sets of numbers. The mean is the average. Add up all the values and divide by the number of values. It's a simple yet powerful tool. For instance, the mean of the test scores 70, 80, 90, and 100 is 70 plus 80 plus 90 plus 100 divided by 4 equals 85. This gives us a quick snapshot of overall performance. The median is the middle value when the data is ordered. It's particularly useful when our data set has outliers. In our example, the median is between 80 and 90, which is 85. This can sometimes give a better sense of the data's center than the mean. The mode is the most frequent value. It tells us what is most common in our data set. If all scores are different, there's no mode. This can happen in diverse data sets. These measures help us understand the typical value in our data, providing insights into trends and patterns. For example, knowing the average test score can tell us about the overall class performance. It helps educators identify areas needing improvement and celebrate successes. Frequency distributions and percentages are essential tools that help us visualize and understand the distribution of our data in a more comprehensive way. A frequency distribution tells us how often each value appears in our data, providing a clear picture of the data's overall structure. Imagine a table showing how many students scored within certain ranges on a test. This table helps us quickly identify which score ranges are most common. Percentages, on the other hand, express the frequency of a value or a group of values as a proportion of the whole data set, making it easier to compare different groups. For example, if 20 out of 100 students scored between 70 and 80, the percentage would be 20 divided by 100 times 100 equals 20%. This calculation helps us understand the relative size of each group. This means 20% of the students scored within that range, giving us a clear idea of the distribution of scores. These tools help us see the bigger picture, revealing patterns and trends in how our data is distributed. By using frequency distributions and percentages, we can make more informed decisions based on the data we have. Section 4. Range, variance, standard deviation, measuring the spread. Beyond the center, we need to understand how spread out or clustered our data is. This helps us get a clearer picture of the data's overall behavior. That's where range, variance, and standard deviation come in. These measures give us insights into the distribution of our data points. The range is the simplest, calculated by subtracting the minimum value from the maximum value. It gives a quick sense of the data's spread. Variance and standard deviation are a bit more complex. They provide a deeper understanding of data variability. Variance measures the average squared difference between each data point and the mean. This helps in understanding the data's dispersion. A larger variance implies a wider spread of data. It indicates that data points are more spread out from the mean. Standard deviation, the square root of the variance, is easier to interpret as it's in the same unit as the original data. This makes it more intuitive. A larger standard deviation indicates more variability. It shows that data points are more spread out. For instance, a large standard deviation in test scores might mean that students' understanding of the material varies greatly. This can highlight areas where additional teaching might be needed. Section 5. Real-world applications. Descriptive statistics in action. Let's see these concepts in action. Imagine you're an educator analyzing student performance on a standardized test. You could use the mean score to understand the overall class performance. The frequency distribution could show you how many students scored within specific ranges, highlighting areas where students excelled or struggled. The standard deviation could reveal if the scores are clustered closely around the mean or widely dispersed. By understanding these descriptive statistics, you gain valuable insights into your students' performance and can tailor your teaching strategies accordingly. Section 6. The importance of mastering descriptive statistics in education. Mastering descriptive statistics is crucial for educators. Why? Because it empowers us to make data-driven decisions that can improve student learning outcomes. By understanding the story our data tells, we can identify areas where students need additional support, track progress over time, and tailor our teaching methods to better meet the needs of our diverse learners. Descriptive statistics are the key to unlocking the potential of data in education. Section 7, Conclusion: Embracing the Power of Data in Education. In conclusion, descriptive statistics are essential tools for anyone working in education. They provide a clear and concise way to summarize and understand data, allowing us to make informed decisions that can benefit our students. By embracing the power of data analysis, we can create a more equitable and effective learning environment for all. So, let's keep exploring the world of data and use it to shape a brighter future for education.